Well, hello, and welcome to week 7 of the Math Richmond at Home. And this is Mrs. Allen, and I am the math coach at Bouchal Middle School. And I'm going to be spending the next 2 weeks with you as we go over our probability series, SOL 7.8. Welcome. So let's take a look at where we've been and where we are at and where we are going. So you've partnered with Ms. Whitaker over the past few weeks as she helped you to get a really good understanding about slope. And slope is used to make real-world decisions. For example, Grandma may need a wheelchair ramp added to the house. And the contractor may use slope calculations to make sure the steepness of the ramp is safe enough for Grandma to move up and down. Now, I'm excited that you are here with me over the next few weeks as we learn about how we already do, how we can, and we will use probability to help us make real-world decisions. Probability is the chance that something will occur, and we use probability in life to make predictions for events when we don't know the outcome yet. For example, we are probably not going to cook on the grill outside because Andrew Frieden's weather forecast is predicting a 100% chance of rain today. Now I can look outside and see that in fact it is raining. The word probably helps me remember the meaning of probability. Now you also hear people talk about chance all the time. What are the chances that I will win the lottery? Or what is the chance that we will have a snow day? Or since it's 100 degrees outside, it is impossible that it will snow. Or even since my dog barks every time the mailman comes to the house, it is likely that this is the mailman. Probability is all around us. And we are going to learn about 2 types of probability that uses math to predict outcomes. Theoretical probability and experimental probability will be our focus for the next 2 weeks. You will certainly need supplies each day so that you're prepared for the lesson. So be sure you come prepared with a notebook, a pencil, a calculator, and you have several options for a calculator. You can use the online Desmos calculator, you can use a handheld calculator, or you can use the phone app because a lot of us have cell phones where if you turn your cell phone landscape, it actually turns into a scientific calculator. And last but not least, just as important, is an I can attitude because you can certainly do this. Everybody can. So our learning objective for today is to determine the theoretical probability of an event. There will be many days over the next 2 weeks where we are introduced to new vocabulary. For example, today's vocabulary term is theoretical probability. Theoretical probability is when we use math to predict the likelihood that an event will happen. It's expressed as a ratio of the number of ways an event can occur to the number of likely outcomes. The ratio is important, so you'll definitely will want to remember that. Write it down in your notes. So we often use models in math to give us visuals of what things look like, or in other words, to help us see our concepts. And we can use a probability line as a visual to show us the chance that an event will occur. Now, a probability line is simply a number line that zooms in on 0 and 1. So think about your number line, where you have your integers represented on your number line. And for your probability line, we're actually going to focus on 2 numbers, 0 and 1. 0 and 1 are your focal point on your probability line. So we're going to take our line here, and we're going to represent 0 on one extreme and 1 on the next extreme of our probability line. Now let's look at an example. If I'm in a competition and I want to know the probability of a coin landing on heads when I flip it 1 time, we actually can use probability to make this determination. Now look at this quarter here. I just want to show this to you. This quarter came out in 2020 and it has the most amazing graphic on the back. I encourage you to go around your house and see what quarters you have in the images that are on the back because they all represent different stories. And I've actually attached to your learning plan the story of a medallic artist who for a career has the opportunity to design those images on the back of your coin. So I encourage you to take a look at that when you do have an opportunity, or maybe at the end of this lesson. And so back to the probability that our coin will land on a head. Well, we actually have a formula that can help us work through this. And our formula for the probability of an event is the number of favorable outcomes divided by the total number of possible outcomes. And so in this case, when we talk about theoretical probability of our event occurring, it can be represented by this ratio that is in the form of a fraction. Now I would write this notation as the probability of my coin landing on a head. And first you ask yourself, well, how many favorable outcomes are there if I flip this fair coin? Well, how many heads do you have? We have 1. So our numerator would be 1. And our denominator is represented by our total possible outcomes. We have 2 possible outcomes when we flip our coin. And so we have a fraction of 1/2. Well, where do we plot 1/2 on our number line? Right in the middle of 0 and 1 is where we would represent 1/2. And we know that probability can take the form of an equivalent fraction, decimal, or percent. So think back in the fall to when you were working with your teacher on different ways to represent numbers. Well, how do we express 1/2 as a decimal? Well, 1 divided by 2 gives us 50 hundredths. And we also know that we can represent it as a percent by taking that decimal and multiplying it by 100, which would give us 50%. So when we're talking about probability, you could see it represented in any of these 3 forms. And so this tells us that we determine the probability of a coin landing on heads as equally likely, an equally likely event. So if we toss a coin over and over and over, we can expect that we can land on heads approximately 50% of the time. Now let's look at another example. Look at another example here. So what if we actually take these letters here, A, B, C, and D. We have the following letters. And we want to know the ratio that we could write to show the probability of selecting a Z from one of these 4 letters. So we want to know the probability of selecting a Z from these 4 letters. Now, the total number of favorable outcomes is what? How many Z's do we have in these choices? None. There are no Z's. So 0 would be written in your numerator. Now the total number of possible outcomes is 4, A, B, C, D. There are 4 total possible outcomes, so that gets written in our denominator. So the probability of selecting a letter Z using our outcomes is 0 out of 4. Now 0 divided by 4 gives us 0. Z does not exist in this set of letters. So where would that go on our probability line? Yeah, it would go right down here at 0. 0 as a decimal and 0 as a percent. It is impossible to select a Z out of these 4 letters. So with that being the case, we would label this as an impossible event. And it goes on the far left-hand side of our probability line. Now, using that same example right there, what if I wanted to try something? And what if I wanted to know, well, what is the probability of picking a letter from these groups of letters? The probability of picking a letter. Well, let's take a look at what our numerator would be. Remember, your numerator is the number of favorable outcomes. Well, how many letters do we have? 1, 2, 3, 4. There are 4 letters out of how many total possible outcomes? 4. 4 divided by 4 gives us 1. It is certain that we will choose a letter. So that goes on the far right-hand side of our number line. And that represents 100%. And we consider that a certain event. That is a certain event. Now we have 2 extremes on our probability line. We have 1, which are certain events here, and then we have 0 for impossible events here. And again, these are called extremes, and we always need to keep in mind that the probability of an event will always be between or include the numbers 0 and 1 on a number line. So we've had an example of an impossible event, we've had an example of a certain event, and we've also had an example of an equally likely event. Now let's take a look at some examples of some events that might fall in between these fractions and numbers that we have represented on our number line. So say we wanted to use this spinner right here. Let's look at our spinner. And say I wanted to know what's the probability that we would land on a red section if we spun the spinner 1 time. So let's go ahead and write our notation, probability of landing on a red. And I bet you probably already have it figured out. How many reds are there on our spinner? There's 1 red. Out of how many total possible outcomes? 1, 2, 3, 4. 4 total possible outcomes. So the probability of landing on a red on our spinner is 1/4. And where does 1/4 go on our number line, our probability line? It goes right here between 0 and 1/2. So we'd write 1/4, which is represented as a decimal as 25 hundredths, because 1 divided by 4 gives us 25 hundredths. We convert that to a percent by multiplying 100, which gives us 25%. And we have a label for this one as well. We would call this an unlikely event. Now let's use the same spinner, and we're going to do what we would call the complement. What if we wanted to know what is the probability that we're landing on a color that's not red? That's not red. Well, how many favorable outcomes are there? How many are not red? 1, 2, 3. So 3 are not red out of 4 total possible outcomes. So our probability would be 3/4. Well, where does 3/4 go on a number line? But you already have this plotted as well. 3/4 would go on our number line between 1/2 and 1. And it's represented as 75 hundredths and 75%. And do you know how we would label that on a probability line? You've got it. We would consider this a likely event. This is considered a likely event. And considering this information, we know that when something falls or an event falls on towards the left side of the probability line, then we would say it's less likely to happen. And when something falls on the right side of 1/2, or we would say between 1/2 and 1 on our probability line, we would say it's more likely to happen. And so all the examples that we looked at here were without trials or experiments. We were looking at the number of ways an event could happen if we decided that we wanted to do a trial or experiment. And this is what we consider theoretical probability. So remember, our learning objective for the day is to determine the theoretical probability of an event. And that is the expected probability, and it's expressed as a ratio. So let's look at our word problem example that we have here. There are 3 orange, 2 lemon, and 4 cherry starburst in a bag. What is the probability of selecting a starburst that is not orange? Okay, so I've read the word problem so that I can see what it's asking me. Now I'm going to go ahead and apply my problem-solving strategy as cubes, which many of you are familiar with. So I'm going to circle the number 3. It's in written form. I'm going to write it in numerical form. And I'm going to box the key information. So 3 is talking about the orange color or flavor. I have 2 lemon. I have 4 cherry. And I want to know what is the probability of selecting a starburst that is not orange. I haven't done any experiments yet. I just want to know what is the likelihood that I select a color that is not orange or flavor that is not orange. I've underlined that question. Now that's going to help me make sure that as I solve this word problem, I have all the information set apart. So the probability of not orange. Now see how we have this fabulous picture down here on the right-hand side? We don't want to just count what we see in the picture. We actually want to make sure that we just use the information in the question unless it's asking us to refer to the picture. So our probability is expressed as a fraction, and our numerator represents the flavors that are not orange. So that would be 2 lemon and 4 cherry. So 2 plus 4. And our denominator represents our total possible outcomes. Well, how many starbursts are in the bag? We have 3 orange plus 2 lemon plus 4 cherry. Now let's go ahead and find our sums. 2 plus 4 is a sum of 6. And 3 plus 2 is 5. 5 plus 4 is 9. A sum of 9. So we have 6/9. Well, we want to make sure that this is simplified. You definitely use your calculator, it's available. We also want to make sure that we have what we call the greatest common factor of 2 numbers if it's not in simplest form. So our factors of 6, the numbers that we can multiply together for a product of 6, are 2 times 3 and 6 times 1. And then our factors of 9 are 3 times 3. I'm going to write 3 one time, and then 9 times 1. So of the 2 factors, what's the largest number that both 6 and 9 have in common? That would be 3. So our greatest common factor of 6 and 9 is 3. So we divide both our numerator and our denominator by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So the probability of selecting a starburst that is not orange is 2/3. 2/3 expressed as a decimal, which is 2 divided by 3 using your Desmos calculator, is approximately 67 hundredths when we round it. And 67 hundredths times 100 gives us 67%. This represents the probability of selecting a starburst that is not orange. Now it's your turn to try. So pause the video and apply your problem-solving strategy to answer this question. Resume the video when you are ready to go over it. So let's take a look together at our practice problem. I'm curious as to the problem-solving strategy that you used. I used cubes to identify our numbers, 3 orange, 2 lemon, 4 cherry, and also to underline the question. What is the probability of drawing a cherry starburst, and express our answer as a fraction decimal percent? So the probability of cherry, there are 4 cherry out of our total possible outcomes, 3 orange plus 2 lemon plus 4 cherry. Did you have this answer? If not, do you see the error that you made? Great. Let's take another look at another example. Pause the video and solve the following word problem. When you're finished, come back and resume. And how did you do on this particular word problem? It seems like it's a lot going on, but it's actually not. We know that 25% of the vegetables in Denine's cabinet are green beans. And if she randomly selects a can of vegetables to cook for dinner, what's the probability that she chooses a can of green beans? The problem actually tells us the percent of vegetables that are green beans. It's 25%. So all we needed to do was to find the equivalent representation out of our answer choices, which would have ended up being 3/12, which is equivalent to 25 hundredths and 25%. So as we prepare to conclude this lesson, let's revisit our learning objective and our key concept. So our learning objective was to determine the theoretical probability of an event. And we can determine the theoretical probability of an event by writing a ratio of the number of possible outcomes to the total number of possible outcomes. Your vocabulary cards are here if you need them to revisit them during the lesson, and they are often found in your lessons over the next 2 weeks. Now is the portion of the lesson for you to complete your independent work. And the purpose of independent work is to help you have time independently or individually on your own to strengthen your ability to understand the concept. So for today's concept, it's independent practice for you to be able to understand theoretical probability. So complete the practice problems located in your Week 7, Day 1 learning plan. But be sure to justify your answers by showing your work. Following the independent practice, log on to Dreambox and complete 2 lessons to strengthen your math skills. So let's look at our future connections. So today's learning objective was to determine the theoretical probability of an event. Tomorrow, we will practice more with theoretical probability. I am excited to know about who's partnering with me this week as we go over probability. And there are many other students participating in these lessons, so I invite you to post your avatar that represents you on our Padlet. The address is here on the screen, but the link is also found in your learning plan. Now, as we complete our lessons this week, we will learn a little about clean air. Now, May has been designated Clean Air Month, and there are many resources available to help students like you understand how the air affects us when it is not clean, what steps are being done about it, and what are the things that we can do about it. And today's resource will help you learn about the history of and the purpose of Clean Air Month. So be sure to visit the resources on your learning page as we learn about keeping our air clean for ourselves, the ones we love, and the world. So I'm so glad that you came to partner with me today. I want you to be safe. I look forward to seeing you tomorrow. And I want you to remember, make today so awesome that yesterday gets jealous.